All right, so next problem up here, but we always want to do the same thing first. First thing we'll do is we're going to read that question sentence. So that ending sentence here, how many miles ahead is runner A after 1.5 hours? Everybody, even though we see 1.5 hours here in the question sentence, what is it that we are actually looking for? What are we actually looking for here? We are actually looking for distance. How many miles right here? How many miles ahead, but nonetheless, how many miles? So, boom, right there, we are looking for a distance. And what we know about this distance associated with it is that there have been 1.5 hours that have gone by. So, we'll say that the time frame that we're dealing with for this distance is 1.5 hours. And at this point, that's all we can really extrapolate from this sentence, other than that we are looking for how far ahead runner A is from somebody else. Yeah, the distance between two folks, two objects, two things, but nonetheless, the distance between one point and another. So, with that said, let's now read the context. Let's get the situation here under control. We have two runners that start together and run in the same direction for 1.5 hours, which is right there listed again. So let's imagine that, everybody. We have two runners that start together. Let's have a little circle right there. And then they run in the same direction. So we have one going over here and perhaps another going this far. And when we take a look at that, everybody, are these runners, their distances, is there or is there not any overlap between these two distances? Is there overlap between those two distances? Absolutely is. Absolutely is. And if we wanted to find the distance between this point here and this point there, we would have to subtract. We would have to subtract right here, what's in between. We would have to subtract everything in between the red highlight because this is the overlap. If they were both at these points, the distance between them would be 0. So we have to cut out what they both traveled, and we only want the gap. So because of that, everybody, because of the overlap, what can we do with those two rates to find the true rate? What can we do with the rate for runner A, which is 8 miles an hour, and the rate given here for runner B, which was 6.5 miles per hour? What can we do with them? Absolutely, we can subtract the rates because remember, in these situations where the objects are moving at the same time, if they're going in the same direction, we can subtract the distances after we calculate them. But I think we know that if we calculated the distances individually, that would take a really long time. So we can use the other trick, the other method, instead of just calculating the distances individually and subtracting them, just subtract the rates. Subtract the rates, calculate, and move on with your day and have a good one. So let's go ahead and get that done here. We have 8 miles an hour for runner A's rate right over there, 8.0 miles per hour. And then we have runner B, R with an underscore B, and that is going to be 6.5 miles an hour. And so we said again, we have overlap right here that we will subtract. So my party people, what is 8 minus 6.5? 8 minus 6.5 will give us what? Yeah, that'll give us 1.5. 1.5 what though? Be careful with your units. This was 8 miles per hour, 6.5 miles per hour. So this would be 1.5 what? Miles per hour. Absolutely. 1.5 miles per hour. That is our true rate. Let me write that there in all capital letters. This is our true rate. Let me use the green color over here to highlight this nice and easy. But before we continue, let me just highlight the biggest part of this problem. Like, this is where all of your learning should be happening. It should not be happening when I start calculating over here and possibly make a mistake. Where we are supposed to be learning is over here. Learning that, hey, same direction means that there's an overlap. That's why we're going to subtract to cancel out what they both went through. And then that's my true rate. Once I have my true rate, booyah, we're good to go. Distance equals rate times time. My rate is going to be 1.5 miles per hour. My time is going to be 1.5 hours. And we're going to multiply those together. And that's it. And we're done. Here we go. Let's zoom on in. Let's finish that up. 1.5 multiplied by itself. If you know your multiplication tables, 15 times 15 is 225. But no worries. Here we go. We have 5 times 5, which is 25. Carry the 2. Then we have 1 times 5 is 5. Carry the 2 is 7. Then we'll bring that 0 down. 5 times 1. And then we have 1 times 1. Bring that together, and that's going to give us 5. 7 plus 5 is 12. Carry the 1, and then that'll be 2. And how many decimal places are we bringing back, though? Well, we see that we have 1 decimal place up top, 1 decimal place on the bottom, and that's going to make it 2 decimal places that we're going to bring back. 1, 2. There we are. And that's what makes the correct answer for this problem, 2.25 miles. That's going to be answer choice B. All right, next problem up. So we are here to calculate the mean of 4, 6, 8, and 10. So when we want to go ahead and calculate this, we just want to think about that formula to calculate mean. And that's going to be, we're going to add up all of these values, add them all up, and then divide by the number of numbers. So here's how that's going to look. We're going to say mean equals 4 plus 6 plus 8 plus 10. And then we are going to divide by the number of numbers. And if you've been practicing the same number of numbers for a while, you might get tricked into just putting the last number that you thought of. But remember, you have to count them 1, 2, 3, and 4. So we will divide by 4. So from here, my party people, we're going to go ahead and add these up. So here we are. So 4 plus 6, that's 10. 8 plus 10 is 18. So we'll add these together, and that's going to give us 28. So we have 28 divided by 4, and everybody, 28 divided by 4 is going to give us what? Yeah, that's going to give us 7. That's going to give us 7, and that'll conclude this question here. But I want to make sure you understand that another way that we can think about this, thinking about mean as that balance point, you might be able to tell that something's a little consistent here. You know, it's 2, then 4, or excuse me, 4, then 6, then 8, then 10. They're all 2 apart. So when your numbers are all spread out, you just think about what number is perfectly in the middle between all of them. And in this case, my party people, what is the number that's directly between 6 and 8? Yeah, that's going to be 7. So in the case that all of your numbers are spread out evenly, you're just going to ask, hey, what number is directly between all of your numbers? So you can think about it that way, but I really want to see how we handle the next problems to see if we can use that there.